This video is going to review the questions from our most recent IA test on the properties of addition and multiplication. Please be sure that you watch each of the questions that you missed and write a sentence about your corrections. Question number 1. In this question, you're asked to select each equation that shows the use of the associative property of multiplication. So right away, we need to make sure we know what these words mean, that we are looking for something that is using the associative property, where the grouping is changing, and where we are using multiplication. Immediately, I see that this one has some addition in it, so that's definitely not going to be a choice, and that we can eliminate that because it says multiplication. Then we're going to look for some that don't have any grouping, because associative property has to do with grouping. Well, here are two that are just changing the order. No grouping is taking place. So these next two are an example of the commutative property because they're changing the order. So finally, we need to remember that when you are showing the associative property, all of your numbers need to be in the same order. So that'll help us eliminate our last ones. So I'm going to check the order. 12, 3, and 6. The order of my factors is 12, 3, and 6. Well, here I go in a different order. And really what is grouped is still the same. We still have 12 and 3 grouped together. So that cannot be it. Let's check the order and the grouping here. 17, 2, and 10. 17, 2, and 10. And we have a different pair of factors grouped. That one looks good. 22, 9, and 7. 22, 9, and 7. They're in the same order, and we have a different pair of factors grouped together. That one looks good as well. So there are two correct choices for question number 1. Question number 2. Which of the following would make the statement true? I see that we have 6 plus 4 grouped together, which will make 10, plus 7 is going to be 17. So we're looking for something else that's going to be equal to 17. You could go through and solve each of these, but I would look first to see if maybe this question is trying to demonstrate the associative property, and find another example where it's the same numbers and just the different numbers grouped together. And I immediately see here 7 plus 6 plus 4, same numbers, same order, same operation. We just changed the grouping from being the 6 and the 4 grouped together to the 7 and the 6 grouped together. So this is going to be the only correct answer. All of the rest of these are going to give you a different amount than 17. Question number 3. Choose all of the equations that represent the associative property of addition. We know that for the associative property, that means that the grouping has changed, and then we know that we're looking for problems that use addition. So right away, I'm going to eliminate any ones that I see that have multiplication, because we should be just looking for addition. So this can't be an option because it's showing multiplication, and I have a multiply sign here, so this can't be an option. And then remember in the associative property that we want to keep the same order of the numbers. So I'm going to go through and first check to see about the order. 112, 40, and 11. And then the order has changed here. You can also see that the same numbers are grouped together. So that's not an example of the grouping changing. This is not a choice. I'm going to check the order. 7, 9, and 3. 7, 9, and 3. The numbers are in the same order on both sides of the equal sign, and a different pair of numbers is grouped here and here. So this would be a good choice. 98, 9, and 36. 98, 9, and 36. They're in the same order, and then we have a different pair of numbers grouped together. That's showing the associative property. And then in this one, I can see that we have the numbers in the same order. Yep, they match. And a different pair of numbers are grouped together. So we have 3 examples of the associative property of number 3. Question number 4. Mike worked for 3 days and earned the following amounts. Mike wanted to find his total. Instead of grouping the numbers in this way, putting the 12 and the 17 together and then adding the 8, he did this. He put the 17 and the 8 together and then added the 12. What property did he use? Well, I hope that immediately you saw this keyword grouping, and we know the property that is related to grouping is the associative property. So that helps us eliminate 2 of our answers. Then I hope that you saw that the associative property was still left on 2 of them. And then if you look at the operation that you're using, we are not using multiplication, so the only choice is associative property. He grouped a different pair of numbers together to figure out the problem 2 different ways. Question number 5. Which number sentence is not true? So we need to go through and find 3 that are true and 1 that is not true. I see here 833, 833, and I know that in the associative property, if different numbers are grouped together and we have the same order and the same numbers, that this will be true. So this is a true statement. Here I see the same numbers, 441, 441, and I just have different numbers grouped together. This is an example of the associative property, so it's going to be true. Here I have the same operation. We changed operations, but the same operation is happening here and here. 5, 2, and 3, 5, 2, and 3, same numbers, same order, just the grouping has changed. That's going to be true. It's the associative property. Then let's look at this one. 5, 4, and 1, 5, 4, and 2. So you notice that we do not have the same numbers. We have a 1 here and a 2 here. When we multiply them, we're going to get 2 different answers. We can prove it. 5 times 4 is going to be 20, times 1 would just give us a product of 20. Then 4 times 2 would be 8. Then 8 times 5 would be 40. So those are not going to be equal. D would be the correct choice. Question number 6. Click on a box to choose an expression which makes the statement true. You must select all correct answers. Always, always, when you get these kinds of questions that say you must select all correct answers, go ahead and assume there's going to be more than one right answer, so try all of the options that you were given. So immediately I need to figure out what is on this side of the equal sign. So 9 times 4, I can use my 9's trick and I figure out that it is 36. Then I want to go through and find the amount on each one of these and pick the ones that equal 36. 36 divided by 9, I can ask myself what number times 9 will give me 36. I can work backwards, and the best answer is 4. Or the only answer is 4. 24 plus 12, when I add those up, I get 36. 3 times 12 is 36. And if you didn't already know your 12's facts, of course you could do a 2 by 1 digit problem to solve that. 8 times 4 is 32. Counting by 4s, you could figure that out. 36 times 0 is 0. 6 times 6, 36 lollipop licks. So we can see that we have 1, 2, 3 choices that we would choose, and then 3 that we would eliminate. Question number 7. Which of the following statements are true? And we have to select all the correct answers. Here, so we're going to just go through each one and figure out if they're true or false. This is an example of the commutative property. This is going to be 42. This is going to be 42. Changing the order in multiplication doesn't matter, so that is true. Here we can see different numbers, and we're going to have to figure out what each side of the equal sign is, the amount on each side of the equal sign. 3 times 6 is 18. 2 times 9 is 18. Those are equal amounts. This one is true. Here I see 7, 3, and 5. Repeated 7, 3, and 5. So it's the same numbers. We have the same operation happening all the way across. The only thing that was changed is the grouping. So this will, thanks to the associative property, this will be true. Here I see numbers adding together. It's making me think it's the associative property, but I'm going to check it out. I'm going to check to see that it's the same numbers in the same order. 15, 24, 12. Ooh, it should be 15, 24, 12 in order to be equal. But because we have a 24 here and a 15 here, this side is definitely going to be worth more. So this is not true. All right, 5, 4, and 2, 4, 4, and 5. All right, these are different numbers, so I'm going to have to go ahead and solve each side of this equation to see if it's correct or not. So 5 times 4 is 20, then times the 2 would give me 40. 4 times 5 is 20, then times the 4 would give me 80. So that is not equal, so we would not pick this one. And then this one is an interesting one. It has the same numbers. We have a 3, a 2, and a 3. And we have a 3, a 2, and a 3. It's an interesting problem because the order has been changed and the grouping has been changed. So this is really demonstrating two different properties. I'm going to go ahead and solve it just to be sure. So 3 times 2 is 6, times 3 is 18. 3 times 3 is 9, times this 2 would be 18. So even though this is not a good example of one of our properties, this is a problem that is true. So we have 4 that are true, the top row and this one. Question number 8. Identify the property name that is demonstrated by each equation. This one was a click and drag, but I'm going to go ahead and go through them and type them in for you. This first one, 6 times 1 equals 6. This says that when you multiply a number by 1, it keeps the same number. This is called the identity property of multiplication. And then I'm going to skip down here. 0, when you add, is the identity property, the identity number for addition. So this is the identity property of addition. And then these two, we can see that the order has changed. We are going from 3 and 2 to 2 and 3. 5 and 2 to 2 and 5. When we change the order, we think about CO for change order commutative property. And this one's going to be addition. And then the third one is going to be the commutative property of multiplication. And finally, question number 9. What number belongs in the place of the question mark to make this statement true? This question tricked lots and lots of you. Notice that the operation is different on both sides of the equal sign. So we're going to have to figure this out. We can't just assume that they're trying to do the commutative property, changing the order, because if we use that, it doesn't work when the operations are different. So 6 times 2 equals 12, and this is saying to us 2 plus what number is going to give us 12? Well, the only answer that works is 10. 2 plus 10 equals 12. Many of you said 6 to go here. Let's test out and see why that doesn't work. 6 times 2 is 12, and then if you put a 6 here, you are really doing 2 plus 6. That would only equal 8, which is not enough to equal what's on the left-hand side.